My name is Dwayne Toler. I am from Detroit. I was born and raised here. I started off my career at General Motors, and I felt like I just needed a little bit more of a challenge, so I decided to transition my career into technology. I started off as a full stack engineer, basically like learning the whole MERN stack, MongoDB, React, Node.js. So started off from there, and then as I got more into it, I realized that I liked the back end part of coding a lot more. So I moved towards that, and then eventually I ended up doing a lot of cloud engineering and DevOps stuff. There's a program out of New York called Core Labs where I attended, where I learned a lot of my DevOps and cloud engineering stuff. So that is where I got everything from, and that's how I landed here. So this is what our talk will be about today, mostly how to use DevOps and cloud engineering to scale your startup. What is DevOps? DevOps is some methodology that merges the development and delivery of software with the management of the infrastructure that our software runs on. So basically, like, what that means is after you write code, you have to hand that code off somewhere, and usually you have to hand that code off to like an IT team, and they handle like the infrastructure that the code runs on, and they handle like the pipeline that the code runs through, because you don't want to just write code, push it into production, and then you could have like bugs in the code. You could have a lot of things go wrong. So typically there's a system set up that automates your code delivery. So that's in general like what DevOps is. Cloud engineering is the building and maintaining of cloud services and infrastructure. So basically, kind of cloud engineering, like we know about a lot of different cloud platforms, like Google has GCP, Microsoft has Azure, and Amazon has AWS. And what those platforms do is they have a lot of different services that you can take advantage of. Like one of the more popular ones is AWS, and they have like hundreds of services, and they have a lot of different, like for example, AI services. They also have like a lot of infrastructure stuff. All of them have like, pretty much the specialty is like infrastructure and servers, but then they also have like a lot of different services that have like storage, like AI databases. So like a lot of different things come in like DevOps and especially like cloud engineering. And then another thing that we'll be talking about is automation. That'll be kind of sprinkled out throughout this whole process. And automation is basically using technology to perform tasks with minimal human intervention, and that is very beneficial because a lot of times it just speeds up your process, for one, and then for two, if you have a process that works and you can automate it, that takes out the chance for like human errors, right? So we all write code, forget to put a semicolon or put a wrong letter or something in there. So like those are the things that like kind of automation can help us do. Why we should care about this? DevOps can help us like save money like with our startups. So and one of the ways that we'll be talking about is containerizing our applications so that we can run them in the most affordable cloud environments. All cloud platforms are not built the same. Some are more expensive than others. So by containerizing our applications, and we'll get into like exactly what a container is, but by containerizing our applications, we can run our applications on different cloud platforms and take advantage of whether you want to take advantage of the services on this one cloud platform, or you want to take advantage of the pricing on this other cloud platform. By containerizing our application, we have that portability to go from platform to platform. Another thing is growth with cloud engineering. So cloud engineering allows us access to use the same technologies and services that a lot of large modern companies use, and that will help us grow our startup. So like, for example, I tend to use the AWS platform a lot, and they have a lot of AI products, and a lot of the work in AI over the years has already been done. So like AWS has it basically where you can take advantage of a lot of these different AI products, and just by running commands, you get access to that functionality. So they have one of the services called Amazon Poly. They have Amazon Transcribe. And basically, one thing that you can do, like for example, there was an app idea that I was talking to somebody recently about, and basically you merge those two, right? So Transcribe basically takes your audio, right? So this would be like an idea for content creators, right? So you take your audio and you transcribe it into a bunch of different languages, right? And then you have Amazon Poly that can clone a voice, right? So you create content, have it transcribed, and then have it translated into a bunch of different voices. And now you have this one piece of content just turned into like 15 pieces of content, and that's something that can help your startup or your business grow, because now you've just spread yourself out internationally. So your let's say you got a YouTube channel or something that's like a recipe type of thing, or you do a cooking channel, right? Like your content now has the ability to be international, and you can take advantage of those type of tools really just with like a few lines of code and whatnot. And so as far as cloud engineering, one of the things that we'll be looking at today is load balancers, and we'll talk about that a little bit later. And scaling with automation, right? So once you start to implement these different cloud tools and DevOps systems and whatnot, your startup starts to grow, you start to make money, and then you need to scale, right? Like you have your application and now you go from 15 users per day and now you got 1 million users per day. You need a way to be able to scale your application. You have to have the infrastructure available to be able to handle all of that new traffic that you'll be getting from these different DevOps and cloud engineering strategies that you'll be implementing. So yeah, just a quick diagram of what we'll be going over. We'll go over some application code that's stored on GitHub. We'll look at AWS, and we'll build a Docker container from there. Then we'll go over to DigitalOcean, which is another cloud platform, and we'll build a container from there. We'll build a load balancer with another container. We'll see how Jenkins helps us set up CI/CD pipelines, which is basically like delivering our code from like writing it to pushing it out into production. And then finally, we'll do we'll look at Kubernetes. So we'll start. So we'll start at GitHub. So basically, the code that we'll start with, this is some really simple code. It's just a basic HTML web page, and what we'll do is we'll use AWS and Docker, and we'll build a container, and we'll pull this application up. So we'll start here. So first thing we'll do is we will install Docker. So basically where that came from is Docker. So here, like I have a GitHub repo of a bunch of, so when we talk about automation, right? Like I have a library full of a bunch of scripts that I use like over and over, so that I don't have to go step by step in the terminal and run each command one by one. So that's what I use to install Docker. So we ran this command and we do that. And so we'll check. And then if we can look right here where it says auto Docker, install. So from there, we will and we'll give this file permissions to execute. Doing that, and then we will run this file, and then that will install Docker for us. So I'll refresh this page right quick. But it should come back up for us. All right, there we go. Okay, so now that we got Docker, we'll check and make sure that we have Docker installed. So we'll do Docker -- version, and this comes up, and we see that we do have Docker installed. So from there, what we'll do is we'll start to build our Docker container from a Docker file, and then we'll explain what a Docker file is. So we'll do this, we'll do curl-o this, and basically what this will do is that will download our Docker file for us. And we can look here and we'll see that this is our Docker file that we just downloaded. So to kind of explain like what a container is, essentially like you have your application code, and the way that I like to look at it is we start off with a Docker file, and the Docker file is basically like a recipe, right? So we'll look at this, and this Docker file contains everything that we need to run our application. So we need a server to like kind of direct the traffic that comes into our application. So we use Nginx. These two are not really important, but this is one of the important things right here, this GitHub repo right here. So this is basically what I showed you in the beginning, right? This is a link to my GitHub that we are going to reference in the Docker file, and that is how Docker is going to know where to get our code from. And there's a couple more commands that kind of move a couple things around, but essentially the basic thing is just knowing where to put it in our Docker file and explaining to Docker like where to get our code from. And then another thing we're going to do is expose port 80. And a port is basically kind of almost just like a sliver of a location on a server where we can serve applications and stuff from, and we can direct our traffic to. So what we'll do is we'll do Docker build -t and then we'll take this last line here. All right, so we'll run this, and this will build our Docker container. So running that command basically builds our Docker container for us. And the building of the Docker container is like it's like the process of so like I said, like I look at the Docker file like the recipe list, and then building the Docker container would sort of like, if you let's look at it like a TV dinner, right? So like your TV dinner is kind of like has everything pre-packaged and like kind of ready to go once you get ready to eat it. So building the Docker containers, like cooking the food, like the food or whatever, pre-packaging it into your container and everything and getting it ready, right? So we do this Docker build, and then the next thing we can do is we can do Docker run. So we'll run this command and we get that output. And essentially once we run that command, so Docker file is the recipe, Docker build is cooking everything, putting it together and kind of storing it away. And then Docker run is like, okay, now we're ready to have the TV dinner. We take the package with the food in and everything, microwave it, now it's ready to go. So what we'll do is we'll go to, we'll go here, figure out what our, so we should be able to go here and then go to that port 80. And see our website. So from the standpoint of like startups and growing startups and scaling startups, like I mentioned before, the different cloud platforms have different pricing strategies, right? So right now, the instance that what we're running our application on right now, essentially it costs us about $100 per year. Right here, it's like 101, right? And let's say if we were to need like about 5 servers, this would cost us $505 per year. If we ran this on DigitalOcean, it would cost us $72, which is, it's only saving $29, but you can see on this chart as you start to like scale a business up, right? Basically, like you'd save $145 if you needed 5 servers, but as you get into a more advanced, if you add machine learning or AI capabilities into your application, one of the things that'll happen is you need bigger machines to run these type of functionalities, right? So the pricing starts to get a little bit more impactful, right? So let's say we have a machine that can run some AI for us on AWS, it might cost $3,200, but on DigitalOcean, it'll cost us $1,100. And when you start to scale, let's say we need 5 servers, over the course of a year, that'll be $16,000 on AWS. On DigitalOcean, it'll be $5,700, so you save $10,000, right? So we'll do a quick demonstration of that, creating a same thing that we just did in AWS. We'll go and do that on DigitalOcean, and then we can kind of see like the difference in price, but having basically the same capabilities. So we'll do that. So basically what we're doing is creating a machine right now on DigitalOcean. And we can see right now that machine that we just created is loading right now and it's creating itself. All right, so that is done. And then now what we can do, so we can go into this on DigitalOcean. So I'll wait for that. Okay, so while we're waiting for that, another thing that we can do or that we need to do as far as networking, right? So As we remember before, from our first Docker file, we had open port 80. So one of the things that we need to do is we need to make sure that that port is open on every machine that we create, so that our traffic has somewhere to go. So we have basically like a firewall group, and we'll add what we just made, which is that machine that we named DK777, and we'll add that to it. And that should be, all right, so that's all set. And then now what we can do is, so we'll basically do the same thing. Let's see, we'll grab this right here. So we'll grab this same command. Or actually, let me get that. I'll get it from here. So we can go to our raw file in GitHub, and we'll basically just download our Docker file from there. Then we'll kind of basically do the same thing, curl-o. Then we'll download that Docker file there. And then we'll check and make sure that we have it. All right, so we have that. So what we'll do is we'll do docker build -t, and then, or actually, let's see, we need to log into Docker first. So we'll do docker log in. And then get our Docker token. And then we'll go back here. So now we're logged into Docker, and then we'll take that Docker file that we just made, and then we'll build another container off of that, and then we'll run that same application from here. So we'll do docker build -t. Let's say. And this should work. So now we've built our container, and let's see if we can run it. We should do docker run. Let's see. -d -p /dm app 2:latest. So we should be able to, or actually, yeah, we need to, we need our port. Say where our port is, and then, so we'll do 80, 80. So now we run that, and then we'll go back. We'll get the IP address of this last machine that we created. We'll get it from here. Do this. And then we'll open it on that port. And you see we get the same application, right? So whether we are doing this on AWS with a simple app like this, or whether we're doing like something like a bigger machine learning app, what we end up being able to do is save a bunch of money just by switching cloud platforms and using like the same container that we used before. So that portability allows us to save money. And then Once we save money, then we can start reinvesting into our startups, and we can start using different cloud tools that I mentioned earlier, like the different things from AWS, whether it's like different machine learning stuff, more advanced database stuff, or like in this example, what we'll do is like, we'll create a load balancer, right? And what a load balancer is, it's basically a machine that takes the traffic that comes into your website and it splits it over different servers. So you get to determine what traffic comes into which server. So let's say you have an application that has nationwide customers. You might have a server that is in California and a server that's in New York. And you can split that traffic up between those two, or you can just split the traffic up randomly 50-50 between the servers, which is what we'll do here, because what we want to do is demonstrate how you can have different app designs, different features, different offerings, whatever your application has, and you can run two different versions simultaneously on your website by putting a load balancer in front of the two servers. So what we'll do is, so we take this application here, or this load balancer. So this is a load balancer that's kind of already set up. And then basically what you do is you come here, you choose droplets, and then you'll do, right, so add a droplet. And then we'll add another one. Let's say we'll choose that one. So now we have these two applications up. And if we were to go to, see, it says collecting right now. Now the load balancer, it takes a little while to add the machines to it. But if we were to go to this IP address right here and go to that same port 80, we'd be able to see the functionality, but it would take a little bit too long. So I have one kind of already done for us. So what we can do here is we'll copy that and we'll just basically show the functionality of a load balancer. So we'll go to port 80, and you see we have the same app that we had before, but what we can do, right, we have a completely different version. Once we start saving money by going to different cloud platforms and optimizing our costs, that frees up money to invest in other things like different designs, right? And you can see, if you look at this, you can see like this is like maybe a basic website or something that we might start off with. But as we save money, we can invest in different designs. We can afford to hire people to do stuff, and then now we get a better looking application. And as I'm refreshing the page, this would simulate different people like coming to our website. And essentially what we'd be able to do is like split test and collect some data and see which version of this website causes more people to sign up, which version of this website causes more people to buy certain products. So we could kind of extrapolate and think about the different use cases like for a load balancer and what it can do for your business. Like it might be a certain different background colors, different pricing that you have on your website, but whatever it is. And this is not limited to like, cause right now I just have it set to, you know, three different websites, but you could do 100, right? You can have, your website has 15 different pages. You can split test every single page. You can have 15 versions of every single page on there. So this is something that can really help you really drill into exactly what your customers want and what they respond to. And that's something that, like, this is a cloud engineering tool like I was talking about that can help your business grow. So from here, so the other thing I'll show really quick is Jenkins. So Jenkins is an automation tool. So as we are writing code and everything, like I said, you don't want to just write code and then push it to GitHub and then have it immediately delivered into production. Sometimes you want to, there may be like software updates you might want to check for before you push your code into production. There could possibly be certain things, like one of the things we'll do right now is, let's say we have a policy where we don't allow for certain colors to be on our website. Let's say the color, like the color red, is against our brand policy. So one of the things that we can do, so I'll show this Jenkins pipeline right quick. So here in my GitHub repo, I have a Jenkins file. And this Jenkins file, we have our pipeline here, and then it comes in like stages, right? So you define the different stages that you want your code to go through before it ends up in production. So this first stage, you have, we call this pull the latest code from GitHub, right? So we have Jenkins hooked up to our GitHub, and what it's gonna do is every time that we make an update and push it to GitHub, Jenkins is gonna be watching GitHub to see when we update something, and it's gonna pull that new code in. And then once it pulls that new code in this second stage, it's gonna test the background color, right? And it's just a simple test that we have right now, where it basically just doesn't allow for the color red to be on the website, right? And if we update our code, push it, it'll check for red, and it'll say it finished checking and everything was good. If the color is not red, and if it is red, it'll fail the test. So we'll go here and we'll just edit it from here right quick for the sake of time. So you can see right now, we have that one where the background color is purple, and we'll change that to red, and we'll commit that change, and then we'll go to our Jenkins dashboard, and we'll go to this demo. Log me out. All right, so we're back in there, and if we wait for a second, Jenkins should pick this change up and then start to build the new code that we just implemented. So you can see right now, it just picked up the push that we just made. And we'll go here and we'll see what the console is outputting. So basically, we see up here where it pulled our code, and it says finish checking the background color check failed. And that's kind of what we wanted, because we want to protect, for in this example, we want to protect our production environment from, or our production application from having any of the color red in the background, right? So if we were to go back, if we go back here and let's say we change that to purple, like we had it before. So Jenkins should pick this change up again also. So it already picked that change up, and we should have a successful build with this one. And we'll check the console output. So same thing, it pulled the code from GitHub, finished checking the background, and it finished with a success. So essentially, like if we extrapolate that, we can put anything in our pipeline that we want to put in there. It can check for something like passwords in our code. We could have, you can even put infrastructure into Jenkins, right? So let's say we make an update to our code, we can have it check like the capacity of whatever servers that it's on currently, and then if it doesn't fit what we think the traffic needs would be for that, we can have like Terraform implemented into Jenkins, where it just builds out entire infrastructure right inside of this Jenkins pipeline here, right? So we can create stages, and as long as, you know, and we can do any programming language, as long as you can like SSH into a computer from here, you can run different scripts and different languages or whatever in here. And essentially, like I said, you can do anything in this. So this is something that you can use just to automate anything that you want before you actually push your code into production. And then the last thing we'll do, we'll look at Kubernetes right quick. Now, Kubernetes takes like a long time to download also, but what we'll do is we already have some stuff set up, so we'll just kind of take a look. Well, actually, we'll look at some code first. So essentially, this is some code to create a Kubernetes cluster. So basically, right here we'll download EKS, which is Amazon's implementation of Kubernetes. So we download that, and then right here we have a cluster. We name it HDemo1. Couple other things, but the most important thing right here is node group, right? And node group is basically a group of servers, right? So what we can do here is we can specify like the size of the servers and the different specs that we want for our servers. We name it demo front end, and then we can specify the number of servers that we want. We can specify a minimum number of servers and a maximum number of servers, right? And this gives us the ability to auto scale, right? So we start off initially switching cloud platforms, saving money. Once we save money, we invested in different tools like load balancers, and then we start to, we pay designers to give us different versions of our website. Now that we are kind of honing in on like exactly what our customers want, kind of like grasping a lot of the market, and it's causing our business to grow. And now we go from the 20 users per day to 600,000 users per day or whatever. So we need something to scale. And what Kubernetes does is it takes Kubernetes. It's a container orchestration system, right? So these containers that run like on these servers, our servers happen to die sometimes, or let's say our servers are under attack from like security, different security issues or whatever, right? What Kubernetes does like this, it will always make sure that we have at least one node going. Ideally, we want two, and at the maximum, let's say we have an app like a food delivery app, right? So we know like with food delivery at 2, 3, 4 o'clock in the morning, it's not a lot of people really using the food delivery app. So if our app is running in Kubernetes, Kubernetes will scale our app all the way down to one server. But when lunchtime or dinner time comes around and we start to pick up traffic, Kubernetes will see that we have this traffic incoming, and it can scale up to 10 servers. One thing I'll just show right quick with Kubernetes is, let's see. So what we have right now, let's see. So this is where you've seen before, like we named it H1 demo, and then we named it front end. So what we'll try to do is we'll try to do a mock server crash, right? So we'll just terminate this, and then this will kind of be representative of like if one of our servers crashed or something, or is under some type of like security attack or something. So we'll terminate this, and then what Kubernetes should do is just automatically, as soon as it recognizes that this server has went down, should bring it right back up for us. So we have this one, and we can see this one is shutting down right now. All right, so that's terminated, so it should be. Yeah, so what should be happening is it should be bringing up another server for us. Let's see if I can do it this way. Let's see, we'll try it like this. All right, so we'll come back to that and see if we can get that to work in a second. But what we'll do is we basically have the same type of setup that we had with DigitalOcean, and on the regular AWS we have that in Kubernetes as well. And this is behind a load balancer, so we can go to the Kubernetes version of our website hosted, and see it's the same app that we have up here. And let's see if we can do one more thing right quick. So one other thing that we should be able to do is so we'll do KUVCL F so we should be able to delete this, and Kubernetes allows you to kind of switch out your containers like very fast also. So if you, let's say you roll out a new version of your website and somehow the CI/CD pipeline doesn't catch whatever bugs that you have it set up to catch, you can easily roll back to a different version of your website, or whatever the last version of your website that you had working. So now we just kind of deleted the current version, and we should be able to go and do this. Let me see, no. We'll do apply right here. And in 1 second, that should be pulling up our new version. All right, so you see we just reloaded that, and now we have this, our previous version, right? So whether we want to do that manually, which you shouldn't, but you can, automate that, put that in the pipeline, and let's say you have some test in the pipeline. Say you do like a load test, right? You push out a new version of your website, and then you put a load test in there where you simulate some traffic, send a bunch of traffic to your server, and you see that for some reason the website isn't handling that much traffic. What you can do is you can easily roll back by taking like a command that the command that I just put in there, which was the kubectl apply demo.yaml. You can put that into your pipeline. It'll automatically roll back if, let's say, a certain percentage of the test traffic doesn't facilitate it like it's supposed to. And just a quick thing on these YAML files. So basically, this is like a very simple file that you implement in Kubernetes. The important thing right here is basically this image name right here. So this is that container that we made earlier. That's all you have to do is just kind of put that right there, and then we have a different image name right here. And as long as you can just apply that, you can put that in the script, you can swap out different versions of your website like that fast, like as fast as we just saw. Yeah, that's it. That's all I got. And any questions? Go ahead.
You were using like a lot of like Docker, like manual commands, so like CLI commands and stuff. I'm just curious as to why maybe you are using like Docker compose, like in this example, in addition to like a Docker file or some of those CLI commands.
Just to like keep it like as simple as possible. Yeah, just for the presentation purpose, I wanted to, cause like the concept of like containers and then container orchestra, like a lot of that get like super complicated. So I just kind of wanted to make like the most basic version that I could, you know, to hopefully translate it, you know.
Yeah, that makes sense.
Yep. That's it? Anybody else? Go ahead.
Yeah, so I don't have much experience in terms of like basic, like the DevOps stuff that you're talking about. So I just want to clarify. So, like, I think I just need a little more understanding of what Docker is. Are you using it as, like, I want a container. Are you using it as a container, like what lives inside that container? Was it the different versions of the websites that were held within the container? Did you deploy them to different platforms?
Yeah, so what lives inside of the container is basically all of this stuff right here, right? So right here, the most important thing, right? We have our application code right here. So this is the link right here. Actually, if we go to this link, we should be able to see our code if we go to this link. Yeah, so that link right there in the Docker file is basically just pointing us right to where our application code is. And right here is our server, right? So once our traffic comes in, we need a web server to kind of like orchestrate the traffic. So basically like a traffic manager, right? It says go here, go there, or whatever, right? So this is what we use Nginx for. So that's everything that's like in the container. And basically, so to go back to like that food example, right? Our Docker file is like the recipe list, right? It has everything that we need to run our application, right? And once we put it into this Docker file, and then we run that build command, that's like taking this recipe list and all the ingredients in here and cooking everything up, packaging it all together, sealing it up, and kind of storing it away and waiting for us to be able to use it, right? Like a TV dinner, right? So once we get ready to use it, if we keep with that TV dinner analogy, running the Docker run would be like taking that TV dinner and putting it in the microwave with our utensils and everything, and now it's like ready to eat, right? So for our code, we'd have the Docker file, we run Docker build, and that's when we build a Docker image, and then once we run Docker run will take that image and turn it into a container that we can run, right? So it's basically packaging everything up, everything that our application needs, and that's why we're able to go from AWS to DigitalOcean, or we could go to Azure, like whatever, because everything that we need to run this application is packaged into this file. Like, and even if you get a more, because I just did like a simple one here, you can get a way more complicated, application that might need a database and like all of that stuff, but essentially you can package all of that stuff up into one file and then transport it like anywhere. And Docker is just the image, or it's just it's the technology that allows for you to do that. Yeah. Yeah, go ahead, one more.
Yeah. So I'm a full stack dev, and like I like thinking about stuff like this and employing tactics or whatever. But one thing when I converse with peers or like my coworkers, we talk about containerized development. Like here we're like deploying an application to be served by whatever, you know, whatever service we're using. Like how do you feel about containerizing applications for development purpose? Kind of like a holistic, but sometimes people like to containerize just the database or whatever, but I'm of the camp where I think it's fun to just containerize everything that way. For whatever reason, if I need to use another machine, I can just spin up whatever it is I'm working on.
Yeah, I think it's a good idea. I think it's so simple that everything, like you said, should be containerized. Now, whether you actually use it or not, that's a whole different story, but at least containerize it so that you have the ability to use it. So that's like my philosophy on it. Like whether you containerize a database or the whole app, or like you said, like a development environment, like whatever, I feel like everything should be in a container because you can just do whatever you need to do with it, right? It's like instead of like having to go to a restaurant and like all this stuff, you got a TV dinner, all you got to do is pull it out, put it in the microwave, and you got a whole meal ready to go. So that, yeah, I feel like everything, to be honest. Yep.
Thank you.
Yep. That's it. All right. Thank y'all for listening, and yeah, we out of here now.
What's your Git?
So my GitHub is it is DJ Toler. So DJ Toler. Yep, you're welcome.